Salam Sejahtera, I'm Devashni Saravanan from 4BNB going to present my final year project. Title is Development of a Biodegradable Panel using Rice Straw and Sawdust for an Acoustic and Thermal Properties. Abstract. The expanding use of acoustic panels in industry, particularly as acoustic of buildings, had increased demand for them. However, the synthesis used in most of the commercial acoustic products cannot be disposed in natural way as solid waste or burned in industry. Moreover, it gives an effect on human health. Therefore, this study was conducted to develop a biodegradable panel using rice straw, sawdust, and cornstarch to obtain sound absorption and thermal conductivity properties. The samples are divided into three with separate proportions: 70%, 50%, and 30% of rice straw and sawdust with cornstarch as a binding agent. The objectives of this study are to identify suitable proportion of rice straw, sawdust, and cornstarch for biodegradable panel, to measure physical, acoustic, and thermal properties of the panel, and to compare with previous acoustic panels and gypsum board. The mixture was set in a mold and ready to press with hot press machine at 105 degrees Celsius for 15 minutes. Three types of testing were tested: physically, acoustical, and thermal conductivity. The results demonstrate that sawdust with high percentage, which is 70%, and rice straw with 30% had the highest sound absorption coefficient, which is 0.07 at low frequency and 0.9 at high frequency. This sample density is 241.9 kg per meter cubic. The sample with high percentage of rice straw and sawdust had the highest thermal conductivity, and the density is 255.56 kg per meter cubic, which is the highest density compared to the other sample. Thermal conductivity, sound absorption, and density are interrelated, which can be concluded when more sound absorption, the density is less. However, for the thermal conductivity, when the density is higher, the thermal conductivity also higher, increases. Comparing to gypsum board, the lower frequency of sound absorption coefficient at 500 Hz is 0.08, while the acoustic panel has 0.07 at 400 Hz. For the higher frequency, 4000 Hz, the gypsum board sound absorption coefficient is 0.11, while the acoustic panels is 0.9. Therefore, gypsum board and acoustic panel have similar values. The percentage suitable for biodegradable panel is sawdust with 70% and rice straw with 30% were indicated as the ideal materials to replace gypsum board. Next, introduction. From the 1990s until now, research in Malaysia shows that more schools are located in high traffics. The school level averaged between 68.2 and 73.7 dBA, which shows extreme pollution. Technology had made our lives easier. Due to urbanization and infrastructure growth, noise pollution is inescapable and requires innovative approaches. Despite the benefits of synthetic materials in architecture, glass and mineral panels affects human health and environment. Due to the high pollutant concentration, most synthetic materials can be burned or disposed in nature. Acoustic radiation can induce excess vibration and stress in mechanical and electrical systems. Engineers value noise reduction. Active and passive noise control approaches exist. Passive noise control uses porous acoustic treatments, which are good sound absorbers. Sound absorption coefficient measures acoustic energy absorbed by porous, stiff materials. Replace synthetic fibers with rice straw, considering the environment impact, limiting greenhouse emissions into the atmosphere and promoting the renewable energy sources. Health consequences include skin allergies and respiratory disorders. Sound absorption reduces the reflection and absorption of sound waves within a room, which reduces sound audibility. Sound absorption is affected by density, porosity, fineness of fibers, bulk elasticity, thickness, surface treatment, and frequency range. Porous or baffled surface or hollow holes absorb and dissipate sound waves from acoustic room. Acoustic panels are often utilized with fabric-covered bearing frame. Acoustic elements are used to hide air conditioners and speakers. Sound-absorbing items or panels are used in rooms and work areas to reduce reflected sound, reduce noise, improve speech and music listening, and resist reverberation. The absorption coefficient measures absorbency. 0 is non-absorbent and 1 is completely absorbent because different materials absorb different sound at different frequencies. Absorption coefficients are frequency dependent. Then objectives. The objectives of this study are already stated. Next, methodology. Methodology chart is a process involved from the starting until the ending of the study. So firstly, I had find the problem statement and then literature review based on the problem statement. Data collection. Data collection was how the process of the biodegradable panel was going to make. First, find the raw materials and then the mixing process. For the raw materials, I had used rice straw, sawdust, and cornstarch. For mixing, the mixing process was manually and it is a dry mixing process. And then molding hot press oven was used. Once the drying process of the sample was done, I had done the testing. The testing was to find 3 properties of the biodegradable panel. First, the physical property, by done the density and water absorption test. Next, acoustic sound absorption coefficient testing, and then last one, thermal conductivity test. Once find the result and the result was satisfied, therefore I proceed the data analysis and discussion. And once the data analysis was done, conclusion and recommendation was made. Move to the process of panel making. Firstly, process for cornstarch preparation, as shown in the figure 2. Prepare the raw 400 gram of corn flour, weighed up to 10 gram, and add 500 ml of cold water. Mix until there is no lumps of corn flour, and the cornstarch was prepared. Once the preparation of rice straw, sawdust, and cornstarch are prepared based on the proportions for each of the sample, mix the materials together and then assemble the composite materials in the mold prepared. Compact the samples using hot press machine at 105 degrees Celsius for 50 minutes, and the samples was dried in industrial oven for 105 degrees Celsius for 15 minutes also. Once the samples are dried, it is taken out from the mold. Once the sample was done, it was tested for density. The density of the samples was measured, and then for water absorption test, the sample C with highest content of rice straw shows the lowest water absorption. Meanwhile, the sample B with 50% of rice straw and 50% of sawdust shows the highest water absorption of the sample, and sample A with 70% of sawdust and 50% of rice straw was the second highest water absorption. It can be absorbed. Figure 4, 5, and 6 shows the result of the thermal conductivity and sound absorption tested in graph form and bar chart form to be understood more clearly. As shown in figure 4, graph of thermal conductivity versus density shows that samples A, thermal conductivity is 0.334 and the density was 233.33 kg per meter cubic. Meanwhile, sample C, the density is 255.56 kg per meter cubic, and the thermal conductivity was 0.434. This shows less dense acoustic panels have less thermal conductivity. It might be due to the air gaps within fiber affect thermal conductivity. Too much of rice straw touches a hot plate. The densest sample has the highest thermal conductivity, showing that air spaces are insufficient to transfer heat. Therefore, the lower density sample had the lowest thermal conductivity because the air spaces in the rice straw and sawdust fell. Smaller air spaces reduce heat transfer by convection in a sample. Sample A can be utilized as an excellent insulator because low thermal conductivity materials restrict heat transmission, maximize material capacity, operating cost, and reduce energy consumption. Denser width boards can be used as heat sinks, while lower density boards can be used as thermal insulation. For sound absorption coefficient, figure 5 and 6 shows the result at high frequency and low frequency. Figure 5 shows samples A and B. Sound absorption increases with frequency. It nearly hit 0.9 at 2500 Hz to 3900 Hz. Meanwhile, sample C absorption decreases from 2500 Hz to 4200 Hz. Sample C is denser than others. This shows increased board density reduces sound absorption. As the sample density increases, so do the nature fibers per unit area. At the lowest frequency, sample A has the highest sound absorption coefficient, which is 0.07, as shown in figure 6. Sound absorption coefficient of materials effectively increase with the increasing density at lower frequency until 500 Hz, but tend to decrease for denser samples that had higher frequency was more than 2000 Hz. It shows the coefficient of the absorption are greater for less dense samples for denser samples as a result of their highest porosity. Lastly, conclusion. Can be concluded that the biodegradable acoustic panel of rice straw, sawdust, and cornstarch was made, and sample A with 70% of sawdust and 30% of rice straw with lowest density. Meanwhile, sample C have the highest density. The sample C was with 70% of rice straw and 30% of sawdust. Sample A's density affects its water absorption. However, density affects sound thermal absorption. And the high frequency and low frequency sound absorption are 0.9 and 0.07 for sample A. Meanwhile, for sample C, higher sound absorption reduces panel density. It has the highest thermal conductivity. Density enhances thermal conductivity for sample C. When comparing the acoustic panel with gypsum board, the results are not have much differences. Therefore, the sawdust and rice straw material with 70% of sawdust and 30% of rice straw is suitable to replace the gypsum board. Lastly, reference. These are the reference uses. Thank you. That's all from me.